Welcome students to my first session of software engineering. I am Professor Justine Kaur from Khalsa College Patiala. In this series of lectures, we are going to discuss about the introduction and the role of software engineering. First of all, before starting anything, we should know that why we are going to do this. So, thereby we should know that why we are going to study about the software engineering, or in broader terms, we can say that what it is actually, right? Why this is part of your syllabus or curriculum. First of all, we will discuss this thing and then we will move or proceed further. Software development is not an easy task, right? It is not at all an easy task. It is difficult to develop a big system, but it is very easy to develop a program. Likewise, it is easy to develop one system, one software having one user, one developer, and you are good to go. It's like a cakewalk. But in actual, think, is this feasible? Is this possible in real world? Right? Is this possible? No, not at all. No single person can develop a software. It is always being developed by a group of professionals, by a group of team, by a team of professional workers who actually know what to build, how to build, and when to build, we can say, right? So, in actual scenarios, in reality, in industries, or we can say in IT companies, there are multiple users, multiple developers, even developers are from overseas also. One person is sitting in India, in Bangalore headquarters. He is communicating with another person in Chandigarh, Delhi, Mumbai, anywhere. And the other person who is a team leader, he may reside in Canada or in Australia, in America. So it is difficult to develop a big system, or we can say a hard system, having multiple developers, multiple users, and products. It requires a lot of people and planning, which is possible only with proper software engineering procedures. In real life scenarios, we have an example. If you want to build a stream, it's easy. A one person, one worker can build it. But if you want to build River Ganga, can you build that with one person? No, not at all possible. Even if you spend 100 years or any number of years, any ample amount of n years, then even it is not possible with only one person. It requires a team of professional persons who know what construction it needs, what are its bases, what kind of planning it requires, what is the architecture of that, everything we need, right? So likewise, it is with the software. Hope you can relate it with the software too. Why software engineering? Again, the main problem in our software is complexity. Likewise, if you want to build a house, you need architectures which build the map. You need workers who know what amount of cement you need, which paint colors you need. You require painters, right? Building a house is not an easy task. You require number of different persons who know, or we can say who are well suitable in their respective jobs. Likewise, the problem with the software is complexity. The problem is size. Like you can see in this slide, Unix contained 4 million lines of code. Windows 2000 contain 10 raised to power 8 lines of code. So software is all about managing complexity, right? It is all about managing that small programs which you guys build in the computer labs, we can say, like adding two numbers, multiply two numbers. It is all about that. We are managing a big chunk of code, right? Now, the next problem arises, or the next question that arises in your mind, that what is software? In this pictorial representation on my PPT, you can see a computer, and along with that there are some books. What does this signify according to you? This is a computer which definitely requires a piece of code for execution. These are books which have some written material in them. So, software are computer programs and their associated documentation. What do you mean by associated documentation? It is the documentation, or we can say a write-up, a note, a written material which is related to the software or related to the programs which are being built. Like you build a program, right? You have command line in front of it. What does it signify? It signifies what is the meaning of that line. That so equivalent to that, the documentation signify what is the meaning of the software, what we are building, how a layman, how a normal person would understand it. It is all note down in that documentation. Software products can be of two types, broad categories we can say. There are genetic softwares like social networking sites we in our daily lives use. We have Facebook, Instagram, Snapchat, Twitter. We have all these sites. Are these social media sites are built according to you or according to me? No. These are built by taking into account what is the trend, what everyone needs, what the world nowadays need. It is built according to that, right? So it came under the category of genetic software. Second category, apart from generic category, is custom build. Like, I want a website for my college, right? This is my college, my specifications, my requirements, which I want according to my college. So I will go to a software developer in a company, definitely a company which have a software developer, a tester, a designer. I will talk to their team leader, or we can say manager, and I will tell him these are my requirements, and then they will build software according to my requirements. So these are bespoke custom softwares. Next is the evolving role of software. What is evolution? Evolution is how a thing is being developed. Likewise, a human being is evolved was evolved from monkey. How a person is evolved, right? Human beings ancestor was monkey. So likewise, how a software is being developed, it signifies the evolving role. It's a product which undergoes a process and at the same time delivering that product. It has all the potential which is embodied by a computer hardware, or we can say what a computer hardware, what a network of computer hardware can do is done by the software. We need not to install chips. We need not to make sockets to do a certain thing. A software do everything for us, right? Till now, we have studied that why we need to develop software. What is the evolving, how the software is being developed. All the general basic idea we have discussed. Now move on to what actually is software engineering, right? It's an engineering discipline which is concerned with all aspects of software production. Engineering discipline, this word signifies the product is being developed. It is engineered in a way, in a systematic manner, right? So basically, it's an engineering discipline. Why engineering? Because the proper procedures are followed to build a software. Now, the next point is about software engineers. What should they do? How they should behave? They should adopt a systematic and organized approach to their work. It's quite obvious. If the approach will be not organized, not systematic, then all work will be in vain. Then what's the need to make such a big companies? What is the need to do such investments? So much big investments in billions, trillions, if your work is not organized. So the basic first foremost principle is the approach should be systematic and organized. Appropriate tools should be used depending upon the problem to be solved, the development constraints, and the resources available. We should use appropriate tools. I would like to give you an example of this. Like I want to build a website for my college. Definitely, I will use PHP, Java, or .NET. I can't say that I will build it in C or C++. It is not possible. So, the tool we are using here is VB.NET for developing a website, right? The development constraints, we should know what the problems we will face if we are using this tool or not that tool. What are the advantages? We should know. And third, last but not the least point is the resources available. Resources available means, suppose in our software development team, nobody knows VB.NET. Then we can't say that yes, we will build in VB.NET and then we will hire a new person and then he will develop website. No. If we have group of 5 people, 2 of them know Java, 3 of them know PHP, then definitely we will make a choice depending upon that options now. So this is the example of what resources are available to us. Now the next point is the difference between software engineering and computer science. Because students and obviously all people are very much confused that why we need software engineering. We have computer science, then why this is another discipline? Why this another subject we are studying? So I would like to clear your doubt. Computer science is basically theory, fundamentals, algorithms, programs, you can say numerical methods, that how to build something. It is basically just theory or numerical. But software engineering is the procedure to develop complex software products in systematic way by using appropriate models, tools to develop a software. It's basically an engineering. How the product is being developed from starting to end is predefined in software engineering. The phases are predefined. This is the major difference between these two terms, computer science and software engineering. Computer science is insufficient or incomplete when we compare it with software engineering. Practically, in real life, in industries, software engineering is used, not only just computer science. Computer science is used in research, but in industries, in developing a software engineering is used, which I will be going to teach you in the coming lectures, that how we are going to engineer the product by using software engineering. So don't worry, right now, for the time being, just understood this difference. Thank you. Thank you. That's all for today. If you have any query, then please feel free to contact me, ask me through my WhatsApp number, from my email ID, anything you can do. Thank you.